To better understand the origins of planets, let's travel back in time about 4 billion years ago to witness the birth of our very own solar system. Back then, our solar system was a nebula, an unstructured, sprawling cloud of gas and dust floating in the vast expanse of space. Now picture this nebula encountering a significant event, perhaps a supernova or a passing star. This event triggers a monumental pressure change, causing the nebula to collapse onto itself, forming a spinning disk of material. In the heart of this disk, the pressure increases dramatically, leading to a spectacular phenomenon, the fusion of hydrogen atoms. This fusion triggers a burst of energy so immense that it gives birth to a new star, our Sun. The Sun, in its overwhelming grandeur, devours a whopping 99% of the material from the disk. So with the Sun consuming 99% of the material, only 1% was left for the formation of planets. But how did this 1% turn into the diverse planets we know today? From dust and gas to solid, rock-hard planets, the transformation is nothing short of a cosmic miracle. It's a process that is as fascinating as it is complex. Let's take a journey back in time, about 4.6 billion years ago. At this point, our solar system was just a loose collection of dust and gas, swirling around in a nebula. But here's where it gets interesting. These tiny particles of dust and gas started to come together, drawn by their mutual gravitational attraction. This resulted in clumps of matter that gradually grew larger and larger. The young Sun, a fiery ball of gas at the center of this whirlpool, pushed most of the gas to the outer regions of the solar system and evaporated nearby ice. This simple act of solar wind sculpting led to a fundamental division in our cosmic neighborhood. Closer to the Sun, where the heat was intense, the planets that formed were rockier, composed mainly of metals and silicates, the stuff of Earth, Mars, Venus, and Mercury. Further out, where the Sun's heat was less intense, gas and ice could survive, leading to the formation of gas giants like Jupiter, Saturn, Uranus, and Neptune. Then, about 4 billion years ago, something extraordinary happened. A period known as the Late Heavy Bombardment began. Small celestial bodies, perhaps disturbed by the movement of the gas giants, began to collide with larger members of the solar system. It was a time of cosmic chaos and creation, a time when the rough drafts of planets were being hammered into their final forms. This clumping together of protoplanets through countless collisions and gravitational nudges eventually led to the formation of the planets as we know them today. The remnants of this violent yet beautiful process are still visible in our solar system, the asteroid belt between Mars and Jupiter being a prime example. It's a testament to the complex and awe-inspiring process that brought our planets into existence, a process that continues to shape the universe as we know it. While this tale of planet formation is the most widely accepted, it is not without its uncertainties and complexities. Yes, the protoplanet hypothesis currently holds the crown as the best explanation we have for the formation of planets. Our solar system began as a loose collection of gas and dust, forming a disk under pressure, with the Sun consuming 99% of the material. The remaining 1% gave birth to the planets. But the story doesn't end there. The Late Heavy Bombardment, a period of chaotic collisions, and the movement of gas giants that stirred up smaller bodies are all part of this grand cosmic narrative. Yet there are still parts of this tale that remain shrouded in mystery. Scientists continue to explore and study, hoping to unearth more answers. The asteroid belt between Mars and Jupiter, for instance, serves as an intriguing piece of evidence supporting the protoplanet hypothesis. But it also poses new questions. This is the beauty of our universe. The more we uncover, the more we realize there is to learn. So now, the next time you look up at the night sky, remember the cosmic tale of how those twinkling dots came to be. What else would you like to know about our universe?